Hey guys, I just wanted to give you a video on the transformations of functions. We did these in class, but last week was a crazy week and some people missed it or missed parts of them or just had questions, so I thought I would give you a recap on the transformations. So first of all, you had 6 different sheets. In the future, I think I'll make 6 different pictures so that it won't be as confusing. So this same fish, you had every paper that we did, and you were supposed to make a table for the 8 points. So what I meant was these 8 points, you could have used any points, but I just picked some. So these 8 points you needed to put on the table below. Now what you need to look for is the function right here to make sure that you are at the same place that I am. Okay. The first one that I want to go back over is a vertical transformation. A vertical transformation comes when you have a function and then you have a number added or subtracted. In this particular one, there's what my tables ended up looking like. And so you could pause and write those down if you needed to. And then when we graphed it, the whole fish went up 3 units. So if you have a function and you have a constant number added to it, the original is going to go up 3 units. If you have a constant subtracted, it's going to go down 3 units. Okay, so as you can tell, we did a table here when we were doing our groups. We made these tables, and you can make a table, and on this particular one, the x's are staying the same, and think of this as y. F of x we always think of as y plus 3. So we took the y value and we added 3 to it each time, and the x values stayed the same. Okay? If you're just doing one at a time, once you realize what it is that you're doing, you could go to your original and just say, well, I'm going to take each point up 3 units and draw the original and then put your transformation. So that's a vertical. A horizontal transformation moves left and right. This is the one that it's f of x plus 3 in parentheses. So x plus 3 is inside. So if it's inside, plus or minus is moving left and right. Okay? I tried to make an explanation that's not really very good, so you might want to kind of ignore the explanation. But basically what you're going to do is subtract 3 from each x. So you take the x and we do the opposite of what it's saying. When it's inside, we're going to do the opposite. So if you notice here, all of our y's stayed the same, but the x's, we're subtracting 3 from each one. So once you see that this means you're moving left 3 units, you can make the table if that's what you're more comfortable with, or you could just take each point and move it left 3 units. Okay? Now, if it is plus, you're going to move left. If it is minus, you're going to move right. So inside, I always remember it that inside is opposite of what you would think it would be. Inside moves left and right, but plus is going left, minus is going right. Okay? The next one are shrinking and stretching. We can shrink and stretch vertically or horizontally. On this one, we had 2 times f of x. Remember that f of x is y, so this means we're multiplying y by 2. So x's all stay the same, y's multiply by 2 to get this. And how did this graph change? It stretched vertically. Now, if you look at the picture, notice horizontally, in this direction it doesn't change. What changes is that it gets bigger. Now, we're outside, so things happen like you would think it should. If a number is bigger than 1, or if the constant in front is bigger than 1, it's going to make it stretch. If it was a fraction smaller than 1, it's going to, but still bigger than 0, it's going to shrink it down. So if the number in front had been like a third, this would shrink down. Okay? So vertical, stretch, and shrink. The next one is a horizontal stretch and shrink. If we look here, we have 2x inside the parentheses. So again, inside we kind of do opposite of what we think we would do. So we're going to divide x by 2. So our y's stay the same, x is what's changing. Divide the x by 2. This is the table that we get. I tried to make, this should have been an x. I tried to make it to where you could figure it out. So 2 times x equals the original x, so you could say 2 times x equals -4. So when you divide, you get x equals -2. So that's what we get there. That was what I meant for you to do. How did this one change? It shrunk horizontally. Now remember, on the last one we said if that constant was bigger than 1 it would stretch. But remember, we're inside. We said everything inside is kind of backwards of what you would think. So it shrunk horizontally with a number bigger than 1. So if you've got a constant inside, if it's bigger than 1, it's going to shrink. If it's less than 1, it would stretch. So notice it didn't get any taller or shorter, but it shrank in this way. So on this one, the range is not changing, but the domain is. And on this one, the domain stayed the same, but the range changed. Okay, so these are all new sort of things. You may just have to study them and practice them. Okay, the next one we have 2 reflections. Okay, we have 2 reflections. Negative f of x. Remember we said f of x was y, so this would be multiplying y by -1. So all of our x's stayed the same, all of our y's multiply by -1, and they change signs. Okay, so negative f of x, negative f of x reflects over the x-axis. Remember, here the y is changing signs. The y is changing signs. So let's take the eyeball. The eyeball is 5, 2. So the y is going to change. So instead of 5, 2, it's going to be 5, -2. So it flips over the x-axis. Okay, and so this point flipped down here. This point was 3, -3 becomes 3, +3. So it flips up here. So that's a reflection over the x-axis. Okay. Now the next one was a negative inside. We still change the sign of x. Now I said everything inside is opposite. It's still kind of opposite. You really would be dividing by -1, but dividing by -1 and multiplying by -1 is really the same thing. So just remember, if the negative is right in front of the x, you change the sign of the x. If the negative is in front of f of x, which is y, then we're changing the y sign. Okay? So here's the table for that one. Okay, and again, I tried to make an example, and I wrote the wrong letter here. So negative x equals the original x, so if you said negative x equals -4, divide by -1, so x would equal +4. That was how I wanted you to come about that in your groups. But this one is a reflection over the y-axis. So here's our y-axis. So that means that x is going to change sign. So again, if we take the eyeball, we've got 5, 2. So instead of 5, 2, it's going to be -5, 2. So it just flips over here and up. Okay, so this point of 3, -3 is going to change to -3, -3. So it flips over the y-axis. Okay, so I hope that helps. Just a quick little video here. So just remember that f of x is y. So everything that was outside of the f of x happens kind of like you would think. Okay, so here's f of x plus 3 moves up 3. Outside is up and down. 2 times f of x means the y is going to multiply by 2. A negative in front means the y is going to change signs. So all of that is kind of normal stuff. If it's inside with the function, then it's opposite. Here you subtract 3 from your x's, and it moves left here. This one you're dividing your x by 2. Dividing your x by 2. And then here you're technically dividing by -1, but you're just changing the sign of the x because the negative is right with the x. Now, I'm going to stop this video, and then I'm going to do another video for you and put it up of how you're going to use this in your textbook when you're doing problems, and in other places. Sometimes you are going to have pictures like this. You're just going to have some kind of graph that you're just moving, and your problems are going to look like these that we just had. But the next video I'm going to show you is what do you do though if it actually gives you a function. Okay, so that one will be next.